This is our Lab 5 on flow measurement and calibration. I'm Allie, this is Nate, and this is Carson.
So for the setup of the experiment, the goal is to investigate the linear regression equation for the rotameter while calibrating the discharge coefficient of the venturimeter. A venturimeter is a flow measurement device that uses the Bernoulli effect to measure the flow rate in fluids by creating a pressure difference. Students will take three different sets of measurements with different flow rates to further increase our accuracy and understanding of how the flow rate will change the results. The setup of the experiment will use a water table, which consists of a venturimeter and pressure tapping holes connected to the manometer board. A rotameter is connected in line with the system and water is circulated using a pump. The flow is controlled on the water table using a control valve. These are the dimensions for the venturimeter. We'll need these later for calculating the flow rate and CD.
These are our data and results. As you can see over here, this is our run 1, 2, and 3, and our Q theoretical for run 3 was very far off, and that ruined our coefficient of discharge. Down here you can see the graph with our R squared value of 0.501. Possible losses for our values of our coefficient of discharge would be small air leaks, including bubbles, turbulent and non-uniform velocity, or meniscus reading error. Our results compared to be not great, and I believe that's because the venturimeter is more accurate compared to the rotameter.
In this lab, we successfully utilized the tech equipment measurement apparatus to study the calibration of the venturimeter. We investigated the linear regression for the rotameter and calibrated the discharge coefficient across distinct flow rates. Our key findings was that in this experiment, we demonstrated high flow rates resulting in higher pressure difference and a corresponding increase in the calculated discharge coefficient. The discharge coefficient values range between 0.26 to 3.68. While the trend was consistent, the value in run 3 indicates that there was a need for recalibration or a check for systematic measurement errors. The application of this lab was that this lab provided hands-on experience using the venturimeter to measure the flow in a controlled pipe system.
Thanks for
Thanks
watching.
for watching.